Let's look at a sample layout of one quadratic integrate and fire neuron. There's more than one way to do it, and for those of you looking, I have not actually verified that this is complete or correct. Um, Not trying to trick anybody, but this video is really just about expectations of the plan. Um, so this is one of these solder boards, but it actually matches one of your those solderless boards you have. And all I can tell you is that trying to do a plan ahead of time, you might think it's wasting your time and you should just start building and wiring everything up. All I can say is please don't do that. Please plan ahead. So what I like to do is put the layouts of the actual chips that I'm using. There's really only one multiplier. I think there's more than one MOSFET, and this is the 1630 op amps. There's other ones that you can use, but they all don't have the same uh, pinouts. And so what I do is I take that, I can just, and what I'll do is I'll rotate it and just adjust the size so that the pins line up. All right. Um, that's how I just manipulate the image. All right. And then I'll go and have a wire coming in for minus power supply plus power supply. That should actually be VN and VP. Um, and then I wire up everything that I think I'm going to need, like the ground. And then I'll put wires over here for the ground, positive VDD and minus VDD. All right. Now, um, as I'm drawing this, I'll place the parts down and then start adding in the positive power supplies, the negative power supplies, and then wherever I think is ground. But if I were, that's how me drawing it, right? But when I build it, I'm actually going to wire in the power supplies and ground, make sure nothing's shorted. Then I'll do the inverting integrator, right? I'll put that in, and I'll put in the resistors, the capacitor. It was too hard to draw a resistor, so I just made a thing that anything yellow is a resistor. And I know that the resistors have long tails, so I can get away with it. And here, this would be a resistor hanging in free space, soldered into the board, so I can put in the inputs here, right? These are just wires coming out as well. So I would build this portion of the circuit first, do my um, inverting integrator test, right? Then I would add in the initial condition part and add my um, initial condition test. Then you have a choice of whether to do the multiplier or the Schmidt trigger. But then I would just do the Schmidt trigger, not connected to here, but the inputs that is coming from the output of the QIF here. I would just leave that, and I would everything else is connected, and I would just run the test on that. Then I would do the multiplier, where rather than put an input here, I would just sweep some random input and look at the output, right? The transistors are a little bit harder to test like that. But then essentially, if this block is working, this block is working, and that block is working, then you start wiring up the outputs to each other and the feedback. And then if you find a mistake, it's not in the things that you did, it was just in the final connections, right? Now, I can't force you to do it that way, but if you build, what's kind of like a rat's nest, it's going to be impossible for anybody like the TA to help you, right? And probably even uh, doing this and then explaining it to your partner, right? That this goes here, this goes here. You probably will find a lot of your own mistakes. All right. Um, Now, I don't claim that this is a beautiful layout, and I'm not claiming that this one works. This is one way to do your plan for your layout. And and really that's you need to do that. All right, and I'll leave it at that.